All right, so this is Algebra 2, review 1 through 25, part 2. All right, question 10. We got sound on. Okay, so they're going to ask you to solve an inequality. Let's see. Give me a fraction, something like not super easy. How about 5/17? Okay, I'll take your 5. All right, give me a variable. X. Okay. Plus, I need a single digit number. 3. Okay. Greater than or equal to, let's say, -3. Okay, we need to solve and graph this inequality. Solve and graph. Okay, so we're solving for x, right? What's the first easiest thing to do? Subtract 3 from both sides, okay? So we got -5/17. Okay, x is greater than or equal to -6. Okay, now what? Divide by -5/17, so divide by a fraction, right? Can I divide by fractions? You think you can? The short answer is no, but I can do something instead. What can I do instead of dividing by a fraction? What's the opposite of division? Multiplication. Multiply by -17/5. Multiply by the reciprocal. Okay, I can't divide by a fraction, but I can multiply by its reciprocal. Now, what happens to the sign as I multiply by a negative? It flips. So now we need -6 times -17 divided by 5. May not come out to a nice neat number. Again, we made some of these numbers up. 20.4, 20 and 4/10, or 20 and 2/5, right? Okay, something like that, 20.4. Okay, so x is less than or equal to 20 and 2/5. Now, the other part, before we skip this, okay, is it also wanted us to do what? Graph it on a number line. So, here's 0 over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and what, 2/5, 0.4 is a little less than half. So we're right about in there. Is it going to be open or closed circle? Closed, why? Right, because it has an equal to underneath of it. And which direction should the arrow go, left or right? Left, because x is less than. Okay, so we should get something like that, where we're saying, hey, this is 20, this is 21. There's the 2/5 part of it there. Granted, in your question, you're not going to get anything quite that. You should get probably a nice, neat whole number. But I wanted to give you a question that's more complicated than the real question, but similar. So it's good practice. Do we got that? We understand that okay? It sounds like we learned something. We didn't know that we couldn't divide by a fraction. Okay? You all right? Okay. All right. Let's see. We're at 11. All right. On 11, we're looking, it's going to give you a word problem. It's going to talk about a couple different rates. Let's see. Let's talk about different places that you might go that do similar things. Is there anything like similar to like Sky Zone that's not Sky Zone? Trampoline World? Okay. So let's say that we have Sky Zone. Okay. And Sky Zone, I don't know. Let's say that you live close enough to a Sky Zone that you went there quite a bit. Okay? And so they charged you $115 for a membership, but they only charged you $5 every time you went. Okay? So per time. Okay? So there's Sky Zone, and then there's the hated Trampoline World. Trampoline World, on the other hand, let's see, they just charge $7 per every time that you come. Okay? Just flat rate, $7, doesn't matter. Now we want to plan a field trip. Okay, so we want to know, what's going to be most cost effective. Okay, let's say that instead of per student or instead of per time, we're going to say per person. Okay, and this is per person. Okay. We want to know how many people we would have to take for Sky Zone to be cheaper than Trampoline World. How do we set that up? We want to know for how many people is it going to be cheaper to take the high school kids. How many high school kids would we have to take to Sky Zone for it to be cheaper than going to Trampoline World? It's awfully quiet. We're going to see this question on a test. We better start coming up with something. We've got the collective brain power of everybody in this room. What do you do? Well, can I set anything up? Like, can I begin to put together anything? We got some numbers. 115 is a number we have. Okay, and it's just flat rates. They just charge the school $115 just to bring in any number of kids. Okay, plus 5x. Okay, good. It's going to be an inequality, right? Because we want to know for how many Sky Zone is going to be cheaper, less than, okay? And we don't want equal to, right? We want it to be truly less than Trampoline World. 7x. Perfect. Okay, now we just have to solve for x. Subtract 5x. Okay, so we got 115 is less than 2x. Okay? So now what? Divide by 2 on both sides. Okay, 115 divided by 2, that's what? 57 and a half kids. Can we take a half a kid? Right. So we're probably talking 58 kids here. Okay. So we would want to take 58 or more kids, right? 58 or more. If we have 58 or more high school kids, Sky Zone is cheaper. So you can see where a question like this is a valid question, right? If we wanted to save some money. Okay, so we'd look around and we'd check out how many people were going to go and figure out from there. All right, we got that. We understand that. We're going to see it tomorrow. Okay, let's be ready for it. 12. Okay. Let's see. I'm trying to think of a good way to show this quickly. All right. We're going to go car shopping. So it's not really a word problem, but it's kind of a word problem. Let's say we've got dealer 1, dealer 2. We've got car X and car Y. They're going to give us some information here. Okay. Let's see. So we're going to talk about in a certain year, sales of car A and car B by two car dealers is shown on this table. We're going to use a product matrix to find the total profit from the cars for each dealer. So imagine like car X is basically Chevy, car Y is Ford. Okay. So, you know, dealer one, in fact, let's even just call it that. Let's call it Chevy, Ford. Okay, dealer one sold, let's just get a number. How many Chevys did dealer one sell? 23. How many Fords did he sell? 3. Okay, dealer two, how many Chevys did he sell? 2. How many Fords did he sell? 10. Okay. All right, so we've got that. Okay, now we're going to come down and we're going to talk about Chevy and Ford for a second. We got Chevy and we got Ford. Now they're going to give you a bunch of numbers of different types of things. For instance, there is revenue. Okay, there is dealer cost. Okay, and then there is profit. Okay, for that Chevy and Ford vehicle. Okay, right, we want to use a product matrix to find the total profit from the cars for each dealer. Now, I'm going to give you, let's say that the profit on a Chevy is 6,200. All right. So they're going to give you a bunch of these numbers, and I'm just going to tell you right up front that you don't need all of it, okay? Okay, so we have a 2x2 matrix up here in red. Do we see that? We have a 2x3 matrix down here in blue. Do we see that? But are we concerned with revenue or dealer cost? What are we concerned with? Profit. So what I have here is a 2x1 matrix. Okay? What I have up here is a 2x2 matrix. And if I take just that information, right, well, I can multiply those two things. 23, 3, 2, 10 by a 6,200, 8,700. Okay, and I can get my calculator. Now, granted, this is what you're going to show me on your paper. Okay, nobody's logged on, so I can move this kind of out of the way a little bit. Okay, so let's take our graphing calculator. Do we have one? Okay, we're going to go to second matrix. We're going to edit this first matrix. We're going to call it a 2x2. 2, enter, 2, enter. Now, because it's a 2x2 and the other's a 2x1, what I should get is a 2x1 matrix. And so it's only going to give me the numbers that I actually need. Okay? So we've got 23, 3, 2, and 10. Okay? Then we're going to come back to second matrix. We're going to come down. We're going to edit another matrix, matrix B. And it's going to be a 2x1. Okay, 6,200 and 8,700. Oop. Okay, we're going to get out. We're going to select each of them. Matrix A, matrix B. And that's going to allow me to multiply them. Okay. Let's see. And remember that we made these numbers up, right? Okay. So let's see. The total profit from cars A and B for dealer 1. So that's what you're seeing here is profit from cars by dealer 1 is 168,700. Total profit for cars for dealer, total profit from cars A and B for dealer 1, okay, is this first number. Total profit for cars A and B for dealer 2 is down here. Does that make sense? Top one, dealer 1, lower one, dealer 2. Okay, so those will be the numbers that we're looking for, in which case you're just going to write down those numbers, dealer 1, dealer 2. Okay, and they'll be fairly large numbers. Does that make sense? Do we understand how to break that down? Okay. Okay, you're going to be happy to see this one. It wants you to find the determinant of a 3 by 3 matrix. Do I need to work one of these out? Do we know how to do this? Okay. Do we know how to show our work? Great. Nobody in here needs this. Awesome. Okay. By now, you should be able to go back and even find videos on stuff like that. All right. This one we might be a little bit less familiar with. Let's see. I don't know. Let's see. And I can already see where they're trying to trick you with this. On this question, it says classify the system. What do they mean when they say classify the system? Well, not exactly. So whenever they're talking about classify, there's two words they're looking for. Now there's four words to pick from. There is consistent, inconsistent, so it's got to be either one of those, dependent, and independent. Okay? So it's going to come from one word from each of those two groups. So what do I do with this? What is working with that going to tell me? What am I trying to do with it to determine? Okay, perfect. Student said we're going to put this in y equals mx plus b format. Okay, so saying that we do that, right? We've got two equations. What do those equations tell you? Okay, so all right. So if we have, all right. So let's talk about these different situations. All right, if they are the same equation, right? I get the exact same y equals mx plus b. What does that mean? It means they're the same line, right? And if they're the same line, what? Right? Are you looking at that? Are you looking at your notes for that and you know consistent, independent? Yeah. Okay. So consistent. I'm going to trust you because I don't have it memorized. So you're confident there? Okay. Consistent, independent. So if I put those into slope-intercept form and I get the exact same equation whenever it's been simplified, it's consistent, independent. Okay? What if I get Let's look at all the different situations that we can get. Oh. Okay, what if I get the same slope but different y-intercepts? Same slope, different y-intercept, different b. What about that? What does that mean about those two lines? They are parallel. And what are two parallel lines? Inconsistent, independent. Okay? What if I get two totally different lines, different slopes, different y-intercepts? What are they then? No, infinite solutions would be same line. So did you tell me something wrong earlier?
No.
Okay, so they cross. Two lines that cross, what are they? Consistent and dependent, okay? Again, I'm trusting you. So if you got it written down right.
No, you're right. You're right. That one is actually consistent and independent, and then the one up front that has the infinite solution.
Okay, so this is consistent, independent. That sounds more correct. Okay, so up here, this should be dependent. Okay, so hopefully people watch far enough to see this change. Okay? So rather than work all of it out, if we worked it out, you would get an answer, but you might not get what they're showing on here. So I know that I haven't worked this out, but hopefully I've actually given you better information. Okay? Do we know how to take something from the standard form and put it into slope-intercept form? All we really do is solve for y, correct? Okay. All right. That was 14, 15. Okay, graph and solve. Or graph the solutions. I think that's all they actually want you to do is graph the solutions. What do you do first? Multiply. How do I move the negative 7 over to the other side? Huh? No. What is it doing to the absolute value? It's right next to it. Whenever something's right next, like let's say it looked like this. I mean, if it looked like that, what would you say negative 7 is doing? Huh? Multiplying. How do you undo multiplication? Divide it. So you have to divide by negative 7. Okay? Probably should have picked, let's pick something a little bit easier to work with, just for sake of time. Let's say that this is negative 4. Okay, I divide by negative 4 on both sides, right? So I would get absolute value of 7 plus 4x equals what? 4. Now what do I do? Ooh, silence is deadly. Yes, 7 plus 4x equals 4, and 7 plus 4x equals negative 4. I have to solve both possibilities because all absolute values come out as positive, so there's really two available solutions. There's a solution where it equals a positive on the inside of the absolute, and there's a solution where it equals a negative inside the absolute. All right, so subtract 7. Okay, 4x equals negative 3. Divide by 4, x equals negative 3/4. Okay, subtract 7, 4x equals, what, negative 11? Divide by 4, x equals negative 11/4. Okay, so finally though, we have to put this on a number line. So we got 0 over here. Obviously, like negative 3/4 is going to be not quite there. And negative 11/4 is going to be, oh, let's see, 4 will go into negative 11 2 times with 3 left over, 3/4. So it'll be right about there. Okay, and that's the 2 places I would plot. Okay? Does that make sense? Okay. Let's see. What do we got left? What time are you guys out of here? 51? Okay. Well, I'm just going to cover as many as I can. Like, if I don't get to all of them, I just don't get to all of them. Okay? This is more than I really kind of have to do. Let's see. They're going to tell you something about f of x. They're going to give you a complicated situation. Let's call it 4x cubed plus 3x minus 5. They're going to tell you that g of x equals negative 2x plus 12. What they want you to solve, they want you to find f times g of x. So literally, it's just, I mean, you're foiling out. Okay, let's go ahead and change this to a square. Okay, so I have 4x squared plus 3x minus 5 times negative 2x plus 12. All right, so I'm going to distribute the negative 2x to everything, and then I'm going to distribute the 12 to everything, and then I'm going to combine like terms. Okay? Can you guys do that? Okay, so there's 6 sets of multiplication, and then probably 2 or 3 sets of addition and subtraction. Okay, let's see. I don't know if I have time. 17. All right, let me give you this one last thing. If I see something like this, and I'm asked to factor it, okay? Notice that there's no x value. It is x squared minus a perfect square. What do I get whenever I have x squared minus a perfect square? A sum difference. So x minus and x plus of the square root of that perfect square. What's the square root of 64? 8. So the answer is x minus 8, x plus 8. Okay, so if I have x squared minus a number that is a perfect square, my answer will be x plus and x minus the square root of that number. Okay? All right, that is as much as I can give you. That's about 17 questions out of 20. So hopefully that's enough. All right, no problem. Talk to you later. Bye.